Hello, this is Mr. Kissinger, and I'm going to go over this page, this worksheet here that I found that has a lot of the same problems that our students did in their primetime test that they took. And so this page here is designed for students to work along with me, write down exactly what I do on this page, on their page, so that way they understand how to do this better when it comes time for them to do the test retake. Once they have this form filled out completely, along with the little extra things that I'm going to ask students to do off on the side, then they'll be able to do the test retake, and I will take the higher score. So let's get going on this. And again, students, just follow along. Make sure your paper looks like this, and then I will give you some additional problems to do on the side, and just for me to see that you're getting it. So let's go. On question 24, they want us to list all the factors, or all the factors of each number, and the first one is 24. So I know 1 times 24, that works. So I'm going to do the rainbow method here. And then 24 is even, so it goes in by 2. And if you need to, you can do a little division on the side. You can do like 24 divided by 2, that's 12. But if you know that, that's good, and you don't have to show that division. 2 times 12. 3 also goes in. This is where knowing your times tables really helps. 3 times 8. And 4 also goes. 4 times 6. And right here, 4 and 6 are really close together. The only number in between is 5, and so that does not, 5 is not a factor. So our factors are 1, 2, 3, 4, 6, 8, 12, and 24. Now 31 is an interesting number. I know 1 and 31 work. So those are my factors there. And 2, nope, it's not an even number. It doesn't go in there. 3, nope, also doesn't work. 3 plus 1 is 4, and that's not divisible by 3. 4 isn't divisible by 3 nicely. Definitely not 5, because it doesn't end in 5 or 0. 7, nope. 28 gets me really close by 7s, but not 31. And the reason why is 31 is a prime number. So the only factors are 1 and 31. Now, what I need students to do is off on the side, I need you to write the number 28, and I'd like you to write down all the factors of 28 on your own. I'm not going to do that right now. This is my way of checking to see that you understand what we're doing. Question 3, let's go. Give 2 examples of prime numbers and explain how you know. Well, just like 31, I think 31 could be our first example. 31 is a prime number, and the reason we know it is because it only has 1 and itself as a factor. And so 31 is a prime number. Another example of that would be like 5. There are no 2 whole numbers that multiply to get 5 except for 1 and 5, and that's it. So those are 2 examples. What I would like you guys to do is off on the side here, just write one more example. Give me another number that you know is prime. And so here on the test, it also says explain how you know. And what we need to do on the test is in an explanation say prime numbers only have 1 and themselves as a factor. I guess it would be 1 and themselves as factors. My apologies there, guys. Alright, let's go to question 4. Give 2 examples of composite numbers and explain how you know. So I know 10 is a composite number, and the reason I know is my factors there are 1, 10, and that's not what makes it composite. This part here is what makes it composite. 2 and 5. 2 times 5 is also 10. So composite means there's more, it's not prime, so it has factors other than 1 in itself. So 10 would be a great example. 9 would be an example, 1 and 9, but also 3 times 3. That also works. So composite numbers have factors other than 1 and itself, I guess themselves. So off on the side again, I would like you guys to give me one more example of a composite number right there. Let's do question 5. Question 5, we're going to list the 5 multiples of 12. Well, we're just skip counting by 12 here. 12, 24, 36, 48, and 60. That's all we need to do there. And if you need to, you can always add 12 off on the side. It's okay. It's showing your work. I love that. Off on the side of your paper, I need you guys now to do the first 5 multiples of 3. First 5 multiples of 3. Feel free during this, if you need to, like, hit pause over on the side of the paper, write those things out. That's fine. That's like fine. Let's go to question 6. Which of these numbers are square numbers? Well, 25. And the way we talked about square numbers in class is if I had that number of, like, starbursts, if I could take the number of starbursts and arrange it and make it look like a square. And so 25 is actually really, really nice because you have 2, 3, 4, 1, 2, 3, 4 lines in between, which means there's 1, 2, 3, 4, 5 down and 5 across. So this is 5 times 5. There are 25 in there, and that is 5 squared. And so this number is, yes, this is a square number. 36 is going to be 6 squared. 6 times 6. And so that is a square number. 48 is not a square number. The reason I know is 7 times 7 is equal to 49. 6 times 6 is 36. So there's no numbers in between 6 and 7 that are whole numbers. So this is not a square number. So square numbers, we need to explain now. Square numbers are when you multiply a whole number by itself. For example, 2 times 2, 4, 3 times 3, 9. 4 and 9 are square numbers. So, off on the side, tell me if 10 is a square number. Tell me if 10 is a square number, yes or no, and then show me why or why not. Let's go to question 7. Question 7, decide whether each statement is true or false. Explain your reasoning. And so this one is actually straight from the test, the first test. So I know 1 times 18. In fact, I think some of my best explanations are 1 times 18 equals 18. 2 times 9 equals 18. 3 times 6 equals 18. And those are all the factors, so the answer is true. These are all the factors. These are all the factors. All the factors of 18. B. 18 is a square number. True or false? Well, we just talked about square numbers. So I have 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. No. 18 is not a square number. I had a lot of students trying to say 9 times 9, and what they did is they sadly were doing 9 times 2. 9 times 2 is 18, but 9 squared is actually 81, so that doesn't work. Let's go to the next page. On this page here, Write 3 different factorizations of the number 16. Do not use 1 as a factor. So let's look here. 16. Well, 16 is 2 times 8. So that'd be one way of doing it. 2 times 8, that's a factorization. I'm also going to break this up into 4, 2. So that could be 2 times 4 times 2. However, 4 also breaks up. I really should have thought about my space here. 2 and 2. Sorry about that, guys. 2 times 2 times 2 times 2. That is also 16. Honestly, I know it only asks for 3, but we could also do 2 to the 4th power at this point as well. The ones I would really like you guys to know is be able to know this one. Be able to know this one as well. You could have also said 4 times 4. That would have also worked. Many different answers. Off on the side, I would like you guys to do 3 different factorizations of the number 12. Number 2. Use the prime factorizations of 24 and 28 to find the greatest common factor. So 24 and 28, find the greatest common factor. Alright, so 24. Let's do 24 here. Let's do 28 here. Alright, 24 is 4 times 6. We're going to do a prime factorization tree here. That's all we're doing. 2 and 3. 28 is 4 times 7. 2, 2, and 7 is prime. Circle all my prime ones. Now, greatest common factor is which ones are the same. Well, I see 2 2's here. I see 2 2's here. So 2 times 2 equals 4. 4 is my GCF, greatest common factor. You might need to do this on a separate sheet of paper because this I kind of took most of the space here. Could you do the same for 8 and 20? Show it with factor trees and find the greatest common factor for 8 and 20. Then number 3, use the prime factorizations of 24 and 28 to find their least common multiple. Well, we already broke it up, so it's 2 times 2 times 2 times 3 is 24, and 2 times 2 times 7 for 28. Now we know that these are my greatest common factors, so we're going to use this. It's going to be 2 times 2. They both are going here. That's here. That's going to be because they're the same. Now, these guys got left out. The 2, and the 3, and the 7. So now we need to multiply them by 2, 3, and 7. So let's multiply that. 2 times 2 is 4. I'm going to do this off on the side here. 4 times 2 times 3 times 7. Here, let me rewrite the problem up here at the start to make it easier for people to follow. 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is times 7 now. And we have 24 times 7. And I'm just going to multiply this off on the side. I don't know 24 times 7 off the top of my head. Looks to me like it's 148. 7 times 4, 28, 8, 2, yep, 100. Mr. K made a multiplication error. 168. Sorry, guys. So our answer is 168 is the LCM, least common multiple. Again, using 8 and 20, find the lowest common multiple. And you probably can just do it on that extra sheet of paper. Number 4, find the prime factorization of 300. Write your answer using exponents. So let's just break it up right there. 300 is 3 times 100. That's the easiest way to break it up. 100 is 10 times 10. And I can break 10 and 10 and 5 and 2. And I cannot break 5 and 2 anymore. So, mine is 2 times 2 times 3 times 5 times 5. So, and with exponents, 2 squared times 3 times 5 squared. There's my answer. Do the same, this time with 140. If you need to do it on a separate sheet of paper, that's okay. What number has the prime factorization 2 to the 6th power times 5 to the 6th power? Show how you found your answer. And the only thing that worries me about this one is these are going to be huge, huge numbers. So let's just jump on in. 2 to the 6th is 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That is a big number there. Oops, sorry guys. Looks like my computer went to sleep there. Hopefully you guys were able to catch up there. So I got 6 2s, I got 6 5s. Now that looks like if I were to go from left to right and multiply this out, this is going to be a nasty, nasty, nasty process. Let's make this a little bit faster. So I'm going to do 2 times 5, which is 10. So I'm going to rewrite this as 2 times 5, 2 times 5. I'm going to do that 6 times. 1, 2, 3, 4, 5. The reason I'm going to do that is 2 times 5 is 10. So this just becomes 10 times 10 times 10 times 10 times 10 times 10. 1, 2, 3, 4, 5, 6 of them. So when we're all said and done, 10 times 10 is 100. There's 2 zeros there. So very easy. If we're going to do it 6 times, we're going to have 6 zeros. There's my answer. 1 million. It's going to be my answer. So you won't be able to use the same shortcuts on this one, but please guys, try 3 squared times 5 squared. You're going to probably have to do 3 times 3 times 5 times 5 on that. And then last one, is there another number that has the prime factorization of 2 to the 6th times 5 to the 6th? That has that same prime factorization? The answer is no. There is not another number that has that exact same prime factorization. The only number that has that is 1 million. There's other ways of writing 1 million, but they won't be in the prime factorization. So the answer is no. This is the only way to write 1 million with 1 million in prime factorization. Alright. Thank you guys. Make sure you do all the problems off on the side. Show me that you've done this. I would use your old test as something to study off of. Use this as well. And I hope this was beneficial for you. And any questions, you can ask me in class. Thank you very much.